My name is Oliver Schranz. I'm a PhD student and a researcher at the CISPA Institute. So actually, we're a large research site at Sound University. And today I'm going to talk about the research of ours based on Android security. So what we're doing in this talk is actually instrumenting, so modifying and analyzing random third-party applications. All right, so as we're coming from the security domain, there's quite a lot of motivation behind this, because there's a lot you can do with app instrumentation and modification. For example, you want to analyze and reverse apps, of course, particularly the bad ones. But in general, you want to understand what's under the hood, what's going on. You want to do some app behavior monitoring. You want to see what the app is doing at runtime. In some cases, you even want to hot patch vulnerabilities, which means you want to patch vulnerability in the app without relying on the developer to patch them. For example, we had this in an earlier talk, we have a lot of vulnerabilities in libraries, and this might be a possibility to patch the library in an app without waiting for a new app release. So this is typical examples how we use modification and app analysis in the security domain, but there's also a lot of use cases outside of that. So hands up, who ever heard of XDA? Quite some. Okay. So very broadly, XDA is a developer community for people that like to, roughly speaking, make Android their own, which means they want to mod applications, they want to mod the operating system, and they just want to apply any changes here. So it could be anything from just patching YouTube, so it keeps playing music while going to the background, just dropping ads, or whatever you can think of. You can even paint Facebook red, even though that's probably not very useful, but you could do it. So this is actually the domain where we're coming from. We want to do modification of apps, and well, we have quite some use cases for that. And where we're actually coming from here is, at some point we saw that there is a new thing in Android. It's called the Android Runtime. It was already mentioned this morning in the keynote. And the basic idea is that we now have a native compiler on the device that is translating our bytecode to actual native code of this platform. So let's have a look at how that works out. File format. So essentially OAT files, OAT files, are ELF files that just received a new name. And if you follow the flow here, we first transform the stack's bytecode into an intermediate representation, which is really common for compilers. And then the compiler is invoking some optimizations on that, so everything from that code emulation to constant value propagation, so on, so the usual things. And this is something that Google created from scratch. So we now have a complete compiler framework on the device itself. And the reason why many people didn't even notice is because Google did really a great job of hiding this. You still write your apps in Java and Kotlin, have bytecode, translated to DEX bytecode, and now actually executing native code. But you never get ZEC faults, you just get null point exceptions because they embed the complete Java semantics into the native code, which is kind of nice. So actually as developers, we don't see this quite often. We don't care about art at all. But at some point we decided this is quite interesting, so we wanted to have a look. And what we did here was we embedded a complete instrumentation framework into this compiler. So this is what we call ARTist, the Android Runtime Instrumentation and Security Toolkit. And if you have a look, what actually changed is that we added a pre-processing step. So first we have an arbitrary Java library or Kotlin library that we merge into the app. So if I want to modify an application, this is actually my business logic, something that I want to add to the app. For example, an inline reference monitoring implementation or taint tracking, whatever. So this is merged into the app. And if you know a bit about APKs, you know that by this I actually break the app signature, which means it doesn't get any updates now. But it's actually a solved problem for us, but I'll come to that. Then this new code that also includes our code is transformed to this intermediate representation. And the very interesting step here is that we added another step here. And this ARTist instrumentation essentially is applying all the changes that we want to have in the app. So kind of this code that's executed now is stitching together the original app and a new app code. So kind of this is the duct tape, this is the glue sticking everything together. And what's really nice about the solution is that this is completely transparent to the compiler. The compiler believes he's just executing arbitrary optimizations. And because we're used to optimizations changing the code a lot, it doesn't bother that we are actually changing the code at will here. And in return this means we can change it at will. We can do anything. And the good thing here is that we are completely platform independent because this happens before the code generators kick in and generate native code. So this works out of the box for all hardware platforms for Android. First. Second, we have close to no runtime overhead because we don't have any expensive hooking like XPosed or something. We just do this in the compiler, and it's a compiled app, and then we're done with it. Also, I mentioned the app signature, and this is a common problem of bytecode instrumentation approaches, where people just change the APK with, for example, APK tool and repackage it. We don't have this problem right here, because we're only working on this copy over here, and actually we don't change the original APK, and the copy is just dropped afterwards. We just change this compiled version. So in the end, everything we need to do is we take the new compiled version, the new OAT file, and replace it with the old one. So this is kind of a swap operation, and we can redo this anytime. So we can also revert this, and this is really not very intrusive, which means we're not touching the operating system at all, including we are not touching the original compiler. So actually, how do we deploy this then, if we don't replace the original dex2oat with our version of ARTist? Well, the idea is that we have a wrapper application. Since I'm horrible at names, I just named this ARTist graphical user interface. So the idea here is that we take the new compiler version, and you can think of it just as a binary. You invoke it with arguments, and the arguments being installed applications, and it outputs OAT files. So what we do here is we use ARTist GUI, and people can just select applications they have installed, click on instrument, recompile, whatever, and then in the background we execute our ARTist framework. And now we have a new OAT file and the original one that the system generated, and we hot swap this. So actually, after that, the application that will be run will be the new one. And as I said, you can revert this at any time. So now it completely depends on what you actually want to do with that. So we are very generic, this is an instrumentation framework. So what we're actually changing about the code is up to the kind of module developer, but I'll get to that later. Very briefly, you can also do this in the operating system. So if you're not focusing on running on stock devices, if you want to have your own AOSP fork or do this on your own device, you can of course replace the original compiler with our version. And then of course you lose this that you don't change too much about the system, but you can also instrument not only apps, but also system components. As you can see on the one side here, services jar. This is actually the jar that contains the complete system server, which means package manager service, application activity manager service, all the stuff. So this is roughly 25,000 methods written in Java, and for the fun of it, we wrote a module that will instrument them. So into all those 25,000 methods, in each single basic block in the control flow graph, we injected a call that used reflection to get the method name. I know it's dirty, but still, bear with me for that one. And this method name is then printed to loghead. So this is quite a lot, right? For everything that's happening on Android now, there's a loghead entry with the name of the method, and actually this worked quite well. So if you run this on an x86 emulator, it's horribly slow, of course, but it works, proving that ARTist is really robust and also scales. And we have quite some interesting projects here, instrumenting the compiler, the operating system, but due to time restraints, just ask me later if you're interested. All right, at this point, you might be interested in why am I introducing yet another instrumentation framework? Well, we have XPosed, and maybe some of you heard of Frida. Anyone? Okay, I see some hands. Well, it's a bit more popular in the kind of reversing domain. So let's have a look why another one. We believe that ARTist fulfills kind of a sweet spot in the design space because, on the one hand, we are, in contrast to Frida, not only targeting developers but also end users. We don't need a device connected to a PC and an ADB connection. We just need to install ARTist GUI on a rooted device. That's it. And actually, root is just required for this one step where we change the compiled version of the original one from the system with ORs. That's the only step. So actually, root is way overprivileged for our case, but if we don't want to change the operating system, we cannot do a thing about it. So as a Linux time would be perfectly fine, but unfortunately, we cannot do this right now. So in general, as you can see in the table, the idea is that we are not very invasive. We don't need any custom recovery. You don't have to flash anything, just a regular user having a rooted device, downloading our app, importing modules, and you can freely start modifying applications and analyzing them at will. So I've been talking about modules a bit, so let me make sure we're all on the same page about that. When I refer to modules, I'm talking about kind of a well-structured abstract functionality that is self-contained. So for example, I mentioned earlier, I can have taint tracking, I can have ad blocking, and all of those would be modules. Think of them like Lego stones that you just put on other apps. You can just add this is modular functionality. You can inject it into arbitrary applications. Well, from ARTist, you have actually two parts. We already saw there's an optimization pass. So whatever the compiler believes is actually an optimization, but is our glue code. And then what we call the code lib is just a random Java or Kotlin library that you write. So you write all your business logic in Java and Kotlin, and then it will be injected into the target app, and the ARTist optimization pass is kind of stitching all the pieces together. And of course, we also have some metadata like the maintainer and so on. So this is pretty new, but we're expanding on that. So let's make an example. Whoever heard of the Stevo library? Cool, nice. Then I don't have to explain a lot. I'm a big fan, I have to say, because if you have this actually in your debug version of the app, it connects your app to the Chrome developer tools, and you can do a lot, like intercepting network traffic, read all the files, access the database. So there's a lot you can do. You can even execute JavaScript in the context of an app. If that's a good idea, it's a different thing, but it's possible. So I said this is meant to be included in the debug version of your app. But what if there are some researchers that try out to inject this into arbitrary applications? And this is exactly what we did, and I will try a live demo now. Let's see if that one is working. All right, so you should see now my device here. Good, it works. And you see the Chrome developer tools. So actually we have it connected now. I just skipped the instrumentation part for time reasons. And we can have an impact here on the complete UI. We can inspect it, we can change the values. We can also, let me just reload this. We can see live the traffic coming in here. We scroll a little bit. As you can see, as you're used to when working with web apps, and TLS doesn't scare us here because just we're getting all the traffic before it is encrypted or after it was decrypted. And what you also can do is, what is pretty cool, is you can have a look at the databases. So actually what you see is a regular Reddit app. We didn't change anything but applying one of our modules. So this is one from Google Play Store, and you can probably just redo this demo at some point. And we can have a look, for example, in the database, where you have, what is this? There's different subreddits. You can see which one actually has advertisements or not. You can see all the descriptions. It's not that nice on the screen right now, but I invite you to check this yourself as soon as we're also releasing the Stevo module. So in general, I just wanted to show you, you can do quite a lot. And whatever you can change in the code, you can do with ARTist. So at some point, even some of the Hiwis had some fun and added here ARTist Stevo recommends to the Google Play Store, or like this really nice post at Stack Overflow. Of course, that actually never existed. It was just locally on the device, but it's nice for some fake screenshots, right? Okay, of course we did also some more meaningful modules, particularly as part of our research. So in the original paper we had a taint tracking system, which means we're following the flow of information through a program and try to reconnect all the different information flows. And the idea was that if an application is, for example, reading your local files or some pictures, is this application in the end sending this to the internet? And of course then we want to ring an alarm and ask a user if this is actually what the user intended. It's quite involved and also a prototype, but there's also a second project that I really like, and this is actually joint work with one of my colleagues that's also here. The idea is that we took apart an application, we moved the complete advertisement code into a different app. So what used to be a regular library call is now an inter-process communication. And we reconnected it through a custom binder protocol, and all of this on a rooted stock device, so no operating system changes involved, which is the magic of ARTist. So this worked kind of well for advertisements. It was still displaying the advertisement as a remote floating view on top of the app, so the user didn't see any difference. But now, from a system perspective, you would argue that the advertisement library is now what we call a distinct security principle, which means the system can distinguish between library and application. So you can now revoke permissions only from the library or only from the application without impacting the other, which is kind of nice. So we're doing quite a lot here, but again, for time reasons, if you're interested in that, just drop by and ask us something. So if you want to create own modules, and for example, if you want to instrument this awesome droidCon Berlin app, then you can do so because everything is open source. We have an SDK now. This is helping you writing this native code. I mean, you know how to write Java and Kotlin code. For the native code, it's a bit involved. We have a template code lib and a template module, the two parts that stick together. And actually, after checking them out from GitHub, you can change them. You just have to build them by running a single make command, because we already have all the build tools and some make scripts ready. So this is straightforward. Push the module, which is a zip file, to the device, and ARTist GUI actually has a UI where you can just tap on the plus, and then you can select it from the file chooser. So this is really straightforward. And then you have this nice screen where you choose the applications, you can choose which modules you want to apply, and you can change this at any time for each application. So this is actually on demand. So we just entered the beta phase, like on Friday. The last things were published and also versioned and so on. So we try to follow semantic versioning. We heard earlier that's very important. We have this new module management in the SDK and some new documentation. So I ask all of you interested in that to try it out. And of course, we're not done yet, not even close. On the developer side, we want to be more professional about this, like having automated releases, having more tests. We want to have a public module place, like you know it from XPosed, where people just can, maybe immediately from the app, download modules from the web and just apply them to the applications. And there's one student of mine working on a bridge between XPosed and ARTist. So some of the XPosed modules are automatically translated to an ARTist module, which means the store would start with just immediately hundreds of modules readily available. And again, if you just don't want to kind of flash something to the device and just want to root it, then probably ARTist might be an option for you. And also what I showed you, replacing the system compiler to kind of instrument the system server and framework classes and so on. Maybe you can even get to that point without changing the compiler. Maybe you just have to, again, recompile everything, switch the files, and reboot the device. I'm not sure, but I think this is possible. So let's see. So in the end, this is a community project. Well, it's pretty young. We are not that many developers right now, but it's actually bleeding edge research. So please have a look and tell us what you think. We're really waiting for feedback. And since we're a pretty young project, you can also already get a say in the project. So if you kind of want to contribute and have some interesting use cases, then just let us know. We are happily talking about this. Talking about which, we have a Jitter chat, and we have most of it, so everything besides the Stephanie module right now, have on GitHub. And essentially, that's it. So I want to say thank you for attending the talk, and I'm happy to take any questions now. Thank you.
Thank you so much. Questions? Perhaps about the community. For how long have you been working?
Well, actually, the roots of this project go back until end of 2015. So actually, I started this as my master thesis, the initial version of ARTist, but it was pretty focused. There was the taint tracking part, and after that we noticed, well, if we have this compiler that has pretty nice opportunities, why not just create a generic instrumentation framework from that? So this is actually the reason where we started, and from that we just iterated, and with new research projects, we extended the API because we needed new modules. So I think, well, it started 2015 and was open sourced last year, but just this new iteration, what we just called it the first beta version, I released just on Friday, so right in time for droidCon.
Thank you so much.
Thank you.
Any other questions?
Hi, so having worked with XPosed a lot before, do you have any way to better deal with obfuscated apps, like apps that use ProGuard? How do you instrument those? Because methods, signatures, names, they change all the time with every update.
I see. Well, this is actually a shared problem. So XPosed, well, as you said, they have the problem, it's hard to detect the method you want to target. For ARTist, you have similar problems, because most of the filters, or most of the modules right now are written against a filter API, and most of the time you just search for method name. But we have one advantage, which is, I had it very briefly on the table, that XPosed is working, as far as I know, on the method level, like you can hook a method and replace it, but ARTist is working on the instruction level, which means you can even kind of detect a method and just change a plus to a minus or something, which means you can be way better in fingerprinting methods. If you know enough about your method, you can find it outside of the method name just by looking at the code, for example. You still have the problem of obfuscation, so this is shared, but it might help you. So you can get even deeper into that. Because you really have to think about this, you see the complete code in a in control flow graph. Each single instruction is represented in this intermediate representation as kind of an object. So this object-oriented version of the code. This is kind of nice. You can work with that and you can extend it at will.